All right. So thanks for the intro, Mung. My name is Arel Lidow. I actually took this class in 2004, or I guess the predecessor to this class. And I think there were like 5 people in the class, so it's great to see that it's grown over time. It's really a pleasure to come back here every year and talk to you guys. I actually worked in finance before this and spoke about what I did then, and then have since moved on to online advertising. So there are a lot of cool problems in online advertising, and today I just want to back up and sort of tell you guys the story of how all this evolved. It's really easy to look at a textbook and see a really elegant theory that's been laid down, but the truth is most of how online advertising came to use auctions was actually very organic, sort of evolved naturally over time. So I think to understand it, you really have to flash back to 1994. And I realized for the first time that many of you in this class may not actually remember 1994. But as hard as it is to believe, in 1994, people really didn't know what the internet was. It was just starting to enter the public consciousness. And people thought of online, they really thought of America Online. Like you'd sign on, you'd check your email, their chat rooms. It was really cool back in the day. And people were just starting to hear about the World Wide Web. Companies were just starting to build websites. And most importantly, 1994 was the year that online advertising was invented. So this was the first online ad ever shown, actually. It was probably the most deceptive ad ever shown. It literally says, if you can't read it, have you ever clicked your mouse here? And it was an AT&T ad, as hard as I believe. And it did pretty well. Like most people had no idea what this was. 7 out of 10 people clicked on it, which by today's standards is really, really good. You're really lucky today if you get 1 out of every 1,000 people to click on an ad. So this was a very successful ad. And this really was the birth of a new industry. This now, $40 billion a year industry. It's hard to believe. Back then, in the early 90s, how you got an ad on a website was a very simplistic model. You literally picked up a telephone and you called up the website or sales team at a website. And you said, I want to put my ad here. And you haggle a little bit over price. And you basically arrive at some CPM, a cost per 1,000 impression value that you're willing to pay. And your ad would go up for a certain amount of time. There wasn't a lot of sophistication to it. It'd be really interesting to see the equations for this because it was very simple. Just haggle over price and decide. So not much actually changed until sort of late 90s. And I think this was the first revolution in online advertising. This was the year that Britney Spears became famous. I don't know if you guys remember that. Do you guys remember Britney Spears came out with Baby One More Time? It was also the height of the .com bubble. Pets.com somehow raised $83 million without business model. It was amazing. And it was also the year that Idealab, which is like the Y Combinator of its day, launched a company called GoTo.com. Here's the homepage of GoTo.com. It actually looks pretty similar, despite the ugly logo here. It looks pretty similar to Google. And their business model is actually very similar as well. They set out to disrupt the classifieds industry. So their business model was that they built a search engine. Actually, they licensed the search technology from Inktomi. They'd allow people to search for whatever they were looking for, and they'd allow advertisers to pay to have their advertisements actually interspersed with the actual search results. It'd be like getting a Google search, except the ads, you can't tell what's an ad and what's an actual search result. And this model actually took off. For a while, people didn't really know whether GoTo would be the big search engine of the future or Google. So it was actually a fairly successful business. And here's how they sold their ad spots. So they built a self-service platform, and advertisers could log in and they could put in a bid value, an amount that they were willing to pay per click. And whoever bid the highest per click got placed up higher in the search results. Now, I think somebody over here asked a really good question about why that actually matters. Why is it better to be placed up higher? Well, here it matters a lot. Because people generally assume subconsciously that whatever comes up first is the most relevant search result. So if you couldn't tell what was a search result and what was an ad, then whoever was at the very top got all the clicks. But their model was very simplistic. It was not a second price auction. Whoever bid the highest per click got placed highest in the search results. And this had some serious issues with it. So the biggest issue was that buyers figured out that they could game the system. So they would log in, and people figured out, what actually happens if I lower my bid? Could I get the same placement? And if the top buyer actually values a click at $5, in this case, they can actually shade their bid. They can lower their bid to $4 and a penny, and they can still get the top spot. So what happened was literally buyers would log in and they would change their bid thousands of times per day. And this wreaked havoc on GoTo's infrastructure. It was very, very difficult for them to maintain this auction system. And as a result, they also made less money. Over time, everybody shaded their bid. There's a lot of variation in it, but over time, prices were actually lower than on Google, which we'll talk about. So fast forward to 2001. So a new company came along called Google. Which, I see a Google shirt over here. So I guess people have heard of it. And I think it was actually in 2001 that they launched their self-serve AdWords product. And this really changed everything. Not only did Google have the best search engine out there, but they really innovated the way that ad space was sold. So they had two major innovations, and both of these were completely organic. They weren't based on theory. Nobody read a textbook. According to In the Plex, book about Google, it was actually just the engineer working on this had these two absolutely brilliant ideas. So first was he implemented the auction as a second price auction, generalized second price auction. And as you guys know, what this means is whoever bids the highest actually pays what the second highest bidder bid. So in this case, if the top bidder bids $5 per click, and the second highest bidder bids $3 per click, then the top bidder wins the top spot, but only pays $3. So this incentivizes advertisers to actually bid their fair value. So in this case, if the top bidder bids $4, they're still going to pay $3. If they bid $5, they still pay $3. So they might as well bid their fair value. So you don't see the same effect of what happened at GoTo.com, where everybody would play around with their bids constantly, and eventually it resulted in much lower bids. And the second major innovation, which actually seems very simple in retrospect, it's hard to believe that nobody else is thinking about this, was that Google tied valuation to click-through rate. What this means is that they very smartly realized that just because somebody bids more per click doesn't necessarily mean that Google is going to make more revenue or effectively more profit off of that. So if the top bidder here is willing to pay $5 per click, and the second guy is willing to pay $3 per click, but the top bidder gets 1 click every hour, and the second bidder gets 2 clicks every hour, Google is going to make $6 by putting the second highest bidder's bid up top versus $5. So this results in a very different ranking of how ads are actually shown on page. And as a result, it maximizes revenue for the seller. Google made a lot more money this way. It's actually kind of shocking to believe. So GoTo.com was later renamed as Overture and sold to Yahoo for about $2 billion. And Yahoo, for as long as they were running their own search engine, actually used basically a first price auction model and didn't factor in actual click-through rate into their valuation. So a lot of academic research has been done on Google's auction model. And people have rightfully discovered that it has a few inefficiencies in it. So one of the biggest things, and by the way, it's worth noting that Google doesn't actually use a pure generalized second price auction anymore. There's a lot more that goes into it, so this is a bit of an oversimplification. But one of the big issues with generalized second price auctions in general is what happens if a bidder values two of the same goods, or two ad spots in this case, at effectively the same value. So what if I'm a bidder and I realize that I get about the same click-through rate if I'm in the first placement or the second placement? So in this case, I get 1 click every 60 minutes if I'm up at the very top, but I get about the same, 1 click every 61 minutes if I'm in the second highest position. So in this case, if I value a click at $5 and the second highest bidder values a click at $3, why would I pay $5 to get a click? Why wouldn't I pay $2.99 just below the second bidder? In that case, I'm going to pay a heck of a lot less for something that's worth just about the same amount to me, because as an advertiser, I really care about how often people are clicking on my ads. So this creates an issue. There's a lot of research into how to actually solve this problem. But as you just learned, Vickrey-Clark-Groves, or VCG, is sort of the canonically right way to solve this. I'm not going to go into a lot of depth about it. It actually gets kind of complicated. The basic idea is this. So we have two bidders, and we're auctioning off essentially two goods. So this is why I'm not in academia. I think in terms of apples and oranges, not equations. But here's a very simple example. We have an apple and orange. We're auctioning off both the apple and the orange. We have two bidders. So bidder A says, I'll pay $10 for the apple, but $9 for the orange. I value them roughly the same. Bidder B says, I'll pay $9 for the apple and $8 for the orange. So in this case, bidder A could just bid $7, get roughly equivalent value for the orange. But here's how to solve the problem. So in Vickrey-Clark-Groves, VCG, the winning bidder actually pays the amount of harm they cause to the second highest bidder. So in this case, if bidder A wins the apple, because they bid $10, they value it at $10, they effectively cause $1 of harm to the second bidder, because the second bidder now has to live with this orange, and they're willing to value the apple, they would value the apple at $9. So they're effectively living with $1 less of value that they could have had. So by charging bidder A just $1, there's no incentive for bidder A to actually bid less purposely to get a worse good, but something that's roughly equivalent in value. So again, this actually gets kind of complicated. We won't go into it much. In practice, it's worth noting that not too many people actually use VCG. The reason being is that sellers actually make less money. And it's also very difficult to explain to buyers, especially if you're running a self-service ad platform. Explaining something like VCG, which is very complicated, is just too difficult. So Google makes more money by not using VCG, and it's easier to explain to buyers. It's also more computationally difficult to implement. So fast forward to current day. So Google has obviously been very successful with their ad model. They're on track to make about $40 billion in revenue off of advertising. Facebook is basically the new AOL. They, a third of all page views on the internet are through Facebook now. But shockingly, most internet ads are actually shown in a very inefficient way. Remember that first slide I showed where somebody picks up the phone and calls up a website? That's effectively what happens for about 70% of all the money spent on banner advertising. It's banners that you see. Literally somebody at an agency picks up a phone and calls up an ad network or a website and says, I'll pay you this much to show you my ad. Gets a little bit more sophisticated, but that's basically the general gist of it. It's absolutely shocking that this is the case. 2012, we have all this really sophisticated technology, and yet most online advertising is still done by somebody haggling over a phone. So AppNexus was founded 2007, based in New York City, and we're basically trying to solve this problem. So what we do is we replace that phone with an auction mechanism. We feel that this is more efficient at serving the right ad to the right user. What we do is every time a user goes to a website, that site makes a request to our servers. And it says, AppNexus, go run an auction and figure out which ad we should show here. Then we reach out, we make a request to thousands of different advertisers, all within about 10 milliseconds. And we say, Amazon, how much are you willing to pay based on what you know about this user? eBay, how much are you willing to pay? We get bids back from all these different bidders. And keep in mind that they're all bidding based on what they know about the user. So if you recently bought something from eBay, eBay might say, oop, this user has a higher propensity to buy, so we're going to bid more on them. So everybody returns their bids. We select the highest bidder. So this basically replaces the phone. It's like real-time programmatic haggling, essentially. And just like Google and AdWords, we use a second price auction as well. So very simple example. You is bidding 2 cents, Groupon bids a penny. eBay would win, they'd get to show their ad, but they'd only pay a penny. Now, in some sense, this is a much simpler problem than Google has. We're not auctioning off multiple ad spots on a page. We're auctioning off essentially one at a time. By the way, we do this 30 billion times a day. So we run a lot of auctions. But there's a lot of hidden complexity to this. Specifically, I mean, we've noticed some major inefficiencies with the second price auction. So here's a good example of one. So in banner advertising, how many times, at what frequency you show your ad to user makes a lot of difference for an advertiser. So if I'm Ford and I show you an ad once, that ad is probably going to be somewhat effective. I showed it to you a second time, you've already seen the ad, so it's going to be a little bit less effective, especially if I show it to you one right after the other. If I show you my ad 100 times, you're probably going to get annoyed. That might actually have negative value to me. So naturally, bidders tend to bid less after they've shown a user their ad. So the first time Ford sees a user, they might bid $5. The second time, they'll bid $2.50. Third time might bid $1.25, and so on. They're going to keep decreasing their bid, usually some exponential function over time. So I modeled this out here. Here's a very simple example of this happening. So here we have Ford, AT&T, and Kraft. And this is the number of times they've seen the same user over and over again. So the first time they all see a user, Ford bids $5, AT&T bids $3, and Kraft bids $2. And so Ford's going to win that auction. They bid the most, and they're going to pay the second price, which is what AT&T bid, $3. And the second time everybody sees that user, so notice now Ford is bidding less. They're only bidding $2.50 because they've already shown the ad to the user, so the user is less valuable to them. AT&T now has the highest bid. AT&T is still bidding $3 because they haven't had a chance to show that ad to the user yet. And Kraft bids $2. So AT&T is going to win that auction, and it's going to pay $2.50, the second highest price, and so on and so forth. So eventually, the price naturally goes down the more frequently you see a user, because everybody's had a chance to show their ads to that user. So in this case, the average bid price is $1.29, and the seller is making about $13 in total. Now, what happens if Ford, the highest bidder in this case, says, we're going to try something a little bit different. For the first 5 times we see this user, we're not going to submit a bid. We're not going to bid at all. And the 6th time we see the user, we're going to start bidding then, but we're actually going to start bidding much less. So what happens? So in this case, we're still running a second price auction. But here, Ford isn't bidding for the first 5 auctions. In the first auction, AT&T bids $3, Kraft bids $2. Kraft ends up paying $2, right? Less than what they would have made in the previous case, and so on and so forth, until the 6th time that we see that user. This time, Ford bids, and they bid $3, but because AT&T and Kraft, the other 2 advertisers, have already shown users their ads so many times, they're now bidding at 33 cents. So Ford wins the auction because they bid $3, by the way less than they would have paid before, but they're only paying 33 cents now, whereas they paid $3 before, they're only paying a tenth of that now. It's kind of crazy. So now, all of a sudden, the average bid price goes down to 33 cents, and the seller only makes $7, almost half of what they made before. Yeah?
Doesn't this strategy in which they bid over and over and over again hurt Ford and what you said, the annoying of the user, if you have the ad show up multiple times?
So you're saying, isn't it, so it's less valuable the second time you show an ad to user? Yeah, so the answer is, advertisers will typically bid to show the user an ad a second time. They'll just bid less, because as you say, it's less valuable. Yeah. In some cases, there's a lot of very sophisticated stuff that goes on, so they may not bid at all. They may say, it's just not worth it for us to show an ad the second time, or we're going to show our ads to the user every other time, or something like that. This is a very simple example of it. Yeah?
Isn't this problem kind of solved if you have a large number of players, because then the price doesn't increase?
Yeah, so as your bid density increases, you have this problem much less. But it also depends on So when you take into account what people know, what different bidders know about a user, then it becomes very different. Because on any given auction, you may have, let's say, Ford, AT&T, and Kraft, and 100 other bidders may be participating. But Ford, AT&T, and Kraft may be the only advertisers that know something about that user. So Ford may know that you've been to their website recently. Kraft may know that you recently bought Oreos or something. And AT&T may know that you're currently a Verizon subscriber. So because they know these things, they're all kind of bidding on a separate good. They're actually bidding much more than everybody else. So all of a sudden you have this situation where you basically have a much lower bid density at a much higher price point. And this actually happens quite a bit. Yeah?
As a bidder, how am I choosing which sites I would want my banners to go onto? Like which sites I'm bidding for?
Yeah, so that's an excellent question. So there's a lot of thought that goes into this. Typically, you use sort of an optimization process. So over time, you basically run your ads everywhere, or where you think that they're going to work. And then you look at what sites are actually working. So where you get the most clicks, or where people sign up for AT&T subscriptions. And over time, you start to spend your money in more concentrated way just on those sites. It's a very simplistic way of doing it, but it actually gets pretty complex how you do that optimization. Sorry, you had a question before.
I don't think it will make any difference in this auction, but why did you lower Ford's first bid price in the second case? Would it make any difference for Ford if it just started off?
Yeah, well, I mean, just to demonstrate that they could actually bid less than their fair value and still win the...
Why would they want to do that?
Why would they want to in this case?
Yeah.
It doesn't actually make a difference in this case. But I'm just pointing out that there's nothing preventing them from not telling the truth in this case. Yeah.
If you have a small number of bidders, couldn't the bidders just collaborate and say, you're going to bid 2 cents, I'm going to bid 1 cent, and we're going to take turns?
Yeah, collusion. It's a big problem.
Okay. Is there an algorithmic way to get around that, or do you just have to have terms of service and lawyers?
I mean, you can look for patterns. So you can actually, look to see what the average price of an ad placement is, for instance, and who's bidding on it. And if you see sudden drops in the price, or the price trends down over time, then you can kind of figure out what's going on. But it's actually very difficult to figure out in practice, and it does happen. There are all sorts of other tricks that bidders use. So another one is called bid stuffing. So each of these buyers probably has a budget, an amount of money that they're willing to spend to show ads. So in this case, if AT&T knows that Ford's budget is $100, let's say, they could bid purposely higher to get Ford to spend more money and to spend out their budget faster, so that all of a sudden AT&T can start winning at a lower price. Yeah.
Just as another answer to the previous question, you can have a minimum bid and minimum separation between the bids to discourage companies from doing that. Even if they did know each other, they can't influence the website and mandates to do this.
Yeah. Right. So that's one methodology for doing that. I've read some papers on random nth price auctions. So there's some theory. I don't think it's actually been tried very well in practice, but what would happen if you actually ran a third price auction or fourth price auction? And what happens if the buyers actually don't know which level they're being price reduced down to? Then it significantly changes the dynamics and actually disincentivizes things like collusion. Yeah.
In this case, does each buyer know how much the other people are bidding?
In this case, they don't. Yep.
What about a system where once people drop out of the auction, you're out of the auction for the entire cycle?
Once people drop out of it?
Yeah, so
So you can never bid on that user again?
Yeah.
That's
I don't know if you can never bid on that user, but you can never bid in maybe this specific time bracket.
like can't bid for next 5 minutes or
Yeah, exactly.
hour
So
or
you
something.
drop them from the auction.
It's an interesting idea. It's an interesting idea. I don't know. I mean, that would also potentially be damaging to sellers. Sellers might make less money because it decreases bid density on subsequent bids. But it's an interesting idea. Potentially worth trying. sellers typically do to prevent against this type of practice. So the best defense that they have today is called price floors. This is equivalent of using a reserve price on eBay. So sellers generally know, what their ad placements are worth to buyers. They know roughly. So what they do is they say, we're not going to allow buyers to buy our ad placement for under this dollar value. So in this case, taking the exact same example as before, but simulate it with a $1.25 price floor. So what happens? So in this case, we run the first 5 auctions. AT&T, Kraft bid. You notice that on auctions 4 and 5, the seller actually chooses not to show an ad at all. So they don't accept anybody's bid because they know that they're probably not getting a fair value for their inventory. On the 6th auction, Ford comes in and they're going to get price reduced, but they're actually going to get price reduced down to the value of that price floor. So the seller says, I'll sell my ad placement, but for no less than $1.25. So in this case, we're not price reducing down to the second bid, we're price reducing down to the value of the price floor. So Ford actually pays $1.25. On the 7th bid, they're also going to pay $1.25. So here, the seller actually ends up making a little bit more money than they made before. So the seller made about $7 before, now they're making $7.25. So sellers actually increased their revenue by putting in these price floors and actually not showing ads on some bids. But this also gets to be a very risky game for sellers. Because what happens if you set a price floor too high or too low? So here's the same example, but with a $1.50 price floor on the right-hand side. So see what happens here is that the seller chooses not to show an ad more often. Ford is going to pay more when they actually win, but the seller actually makes less money than they would have made if they had no price floors. So if they made $7 before, now they're only making about $6.50. So this ends up being a pretty complicated game that buyers and sellers play. This actually happens in real life. I'm not actually, it's not just theory, it actually happens. So here's an example. It's real data. I can't tell you which website this is, but I promise you these are 2 different websites here. On the top, so on the y-axis on both these charts is the win rate. So this is how often buyers are winning as a function of how much they're bidding. So on the top chart here, we see that it's roughly linear. It's basically what we'd expect. If buyers bid at a higher price, they'll win more often. But on the slower chart here, you see some interesting behavior. So buyers never win if they bid less than 90 cents, meaning the seller here has probably put in a price floor at 90 cents. So nobody can win my ad placement if they pay less than 90 cents. What happens is, after 90 cents, everybody's bidding just around 90 cents and is winning. So in this case, the seller's probably put in a price floor that's actually too high because everybody's winning after 90 cents. So there's not a linear distribution of bids after that 90-cent price floor. So this ends up being a pretty complicated game that we deal with every day at AppNexus.